This is a continued video to help with your CR number 20. This is number 5. If you watched part of number 5 on the first video, just go ahead and fast forward to the point you need. So let's break this down with another example. A water pipe has a flow rate of 6 gallons per minute. How many quart bottles could you fill in 3/4 of an hour? Okay, so first of all, we're dealing with gallons per minute, but they want to know how many quart bottles we could fill. And they're discussing here per minute, and then here 3/4 of an hour. So we need to change our units up. So we need to know that there's 4 quarts in a gallon, because we need to talk about quarts instead of gallons, and we need to know that there's 60 minutes in an hour, because we need to talk about minutes instead of hours. So for the first item of business, let's convert our gallons into quarts. You could do the upside down caret method if you'd like. If you know there are 4 quarts in 1 gallon, how many quarts in 6 gallons? And you look here and you say, okay, how do I get from 1 gallon to 6 gallons? 1 times 6 is 6. Oh, so I must multiply 4 times 6. 4 times 6 is 24. So if there's 4 quarts in 1 gallon, there must be 24 quarts in 6 gallons. So instead of 6 gallons per minute, we need to talk about 24 quarts per minute. Now the second item of business is they're discussing per minute, but they want to know about 3/4 of an hour. So again, let's use our upside down caret method if we want. Knowing that you have 60 minutes in 1 hour, how many minutes in 3/4 of an hour? So you take a look and you say, okay, I know about hours, So how do I get from 1 hour to 3/4 of an hour? Well, 1 times 3/4 gets you 3/4. So then you need to do 60 times 3/4 to figure out how many minutes in 3/4 of an hour. So again, you could just do your 60 times 3/4. If you are comfortable with your fractions, 60 over 1, multiply straight across the top, straight across the bottom if you'd like. 60 times 3 is 180 divided by 4. 180 divided by 4, so I say 4 goes into 18. 4 times with 2 left over, 4 goes into 25. So that must be 45 minutes. Now for me, what I like to do is that if I'm taking 3/4 of 60, I like to draw tape diagrams. I find them powerful. So if I know I'm dealing with 60 minutes, and I know I want 3/4 of that, what I do is I simply break my tape diagram into fourths. And I know I care about 3/4 of those. Well, first of all, I'd say, gosh, how could I find how many minutes in 1/4? Well, if I'm breaking 60 into 4 parts, I just do 60 divided by 4. 4 goes into 6 once. 6 minus 4 is 2, bring down the 0. 4 goes into 2015. That tells me in a 1/4 hour, I'm dealing with 15 minutes. I care about 3/4 of an hour. So I know I just have to do 15 times 3. And if you multiply 15 by 3, you'll come up with 3 times 5 is 15. 3 times 1 is 3, and 1 is 4, 45 minutes. So either way, if you're comfortable with your fractions, just go ahead and multiply straight across the top, straight across the bottom, and divide out. If not, go ahead and use a tape diagram. So at this point, we know it's 24 quarts per minute. That means 24 quarts in every 1 minute. And instead of 3/4 of an hour, we want to know how many quart bottles we could fill. We don't want to deal with hours, we want to deal with minutes, so it's in 45 minutes. Again, you can use another upside down caret if you'd like, because once we broke this down, we know we're dealing with 24 quarts in 1 minute. I wonder how many quart bottles could you fill in now? 45 minutes. So then you just say to yourself, oh, okay. connect my minutes up. 1 times 45 is 45. So I said, oh, I got to multiply 24 by 45. So if I'm going to multiply 24 by 45, I'm going to have to long multiply this. 5 times 4 is 20. 2 times 5 is 10, 11, 12. I want to put a placeholder here. Move to the tens place, which is why we have to start here in the tens place. 4 times 4 is 16, put down a 6, carry a 1. 4 times 2 is 8, and 1 is 9. Now we're going to add these together. I hope I'm not making a mistake on my multiplication here. 0, 2 and 6 is 8, 9 and 1 is 10. So it must be 1,080 quarts. Oh, yeah, 1,080, sorry. 1,080 quarts in 45 minutes, which we know is 3/4 of an hour. Now on your actual CR, they ask how many 2-quart bottles. Well, if you were filling 2-quart bottles, you'd have to think about what to do with this 1080. You'd have to do something with that 1080 at that point if you're asking about how many 2-quart bottles could be filled. All right, let's move on to number 6. Number 6, the hint is draw yourself a number line, determine which set of numbers is in neither greatest to least or least to greatest order. So let's just make sure, first of all, we're comfortable with our number line. This is a number line from -10 to 10. Let's take a look at a set of numbers that are in order from least to greatest. If you look at your number line and you start at -5, then you move to the right, -3, then you move to 0 further to the right, moving to 2 is further to the right, and 4 is further to the right. So if they're in order from left to right on a number line, then you're in least to greatest order. So that is a set of numbers that are totally in order. I'm going to take a look at the same set of numbers, and now I want to go from greatest to least. So again, now if I'm starting way over here on the right and I go from 4 to 2 to 0 to -3 to -5, then I know I'm going in order on my number line from right to left. So I'm going from greatest to least. The question on the CR asks you what set of numbers is not in order, either from least to greatest or greatest to least. So let's take a look at the same set of numbers that are now not in order. So if I look here and I start here at -3, you're like, all right, I could start there. And I move left, -5, so -5 is smaller than -3, but then I backtrack and I start moving to the right. No, this is not in order. We move to the left and then to the right, and then the problem is that -5 is actually less than -3. So that's not in order. So it would be a set of numbers like that you're looking for on your CR. The teacher says either put them least to greatest, greatest to least, and you find the one that's not in order. Hopefully that helps. Let's take a look at number 7. Here's an additional example. There's several ways to look at this problem. It says the dinner theater seats 1,200 people. 75% of the seats are reserved. How many seats are reserved? Okay, so what I would do if this was me, I would take a look at a tape diagram because I happen to love them. But there's lots of ways to go about this problem. So I would take a look at a tape diagram. I'd say, okay, the total theater holds 1,200 people. 75% of those seats were reserved. So if I'm fairly comfortable breaking down my percentages, I could say, okay, out of the 1,200, if I broke it here, that would be 50%. The entire 1,200 would be 100%. I need 75%. Well, right in between there would be 75%. Again, if this is 0%, what's right in between 0 and 50? Well, that would get me right here to 25%. And then I just look at my 1,200 and I say, okay, if I care about 75%, I care about 1, 2, 3 out of these 4 parts. Well, how do I figure out these 25% blocks? I just take 1,200 and divide it by 4. going to divide it into 4 parts. 4 goes into 12 3 times. Put that 3 right above the 2. 3 times 4 is 12. Subtract off. 0. Bring down a 0. How many times is 4 going to 0? Oh, 0 times. Bring down the next 0. How many times is 4 going to 0? 0 times. That means in each 25% of the theater, there's 300 seats. And if 75% of those seats have been reserved, all you have to do is take a look at this and say 300 times 3. 3 times 0 is 0, 3 times 0 is 0, 3 times 3 is 9. 900 seats have been reserved. I believe Mrs. Connor looked at it a different way. So what I look at it as, I say 75% is 75 over 100. I simplify that down to 3/4, which is how you could know to break it into 4 parts and that you care about 3 of those 4 parts. And then, of course, I do my tape diagram. Miss Connor, I believe on your the paper she gives you for your CR helper, I believe she looked at something considering percent over 100 is the same as part over whole, and you could do that. You could say I care about 75% out of 100. Well, 100% or the whole theater contains 1,200 people, and I care about what part of the seats have been reserved. And then I could just look here at my equivalent fractions. 100 times what gives me 1,200? 100 times 12. And then I'd have to do 75 times 12 to know how many seats were reserved. 75 times 12 better be 900. Let's check. 75, because even if you do a math problem 2 separate ways, you're going to get the same answer. 2 times 5 is 10. 7 times 2 is 14, and 1 is 15. 0 placeholder. 1 times 5 is 5. 1 times 7 is 7. Let's add this up. 0, 5, and 5 is 10. 7 and 1 is 8, and 1 is 9. Either way you handle it, you get 900 seats have been reserved. Second part of the question says, if your CR question is a little bit different, but if you were looking at if each seat cost $50, how much did the dinner theater lose that evening? Okay, so how many of the seats were not left filled? So if we just look back at our tape diagram, there was 300 seats in our example left empty. So we know we have 300 empty seats. The theater loses $50 on each of those empty seats. $50 on the first seat, $50 on the next seat, $50 on the next seat. So they've lost $50 300 times. So if you just take 300 times 50, 0 times 0 is 0. And then we can start right here. We're now in the tens place. 5 times 0 is 0. 5 times 0 is 0. 5 times 3 is 15. So they must have lost $15,000. Hopefully that helps with number 7. Let's take a look at number 8. The hint for number 8 is change each fraction to have a common denominator, draw a number line, and place each fraction on the number line. So I'm just giving you a number line that's broken into sevenths. The question asks you, it gives you a series of fractions and it says which is closest to 0. So I just want to give you a quick example of 2 numbers and figure out which is closer to 0. Well, if we look at 3 sevenths, I break my number line into sevenths. So on the right side it's positive 1 seventh, positive 2 sevenths. On the other side it would be negative 1 seventh, negative 2 sevenths, and so on. So if I look here and I'm at 3 sevenths, that's 3 sevenths to the right of 0. And if I look at negative 1 seventh, and I look at that distance there, look at that distance there, up to 0, that is 1 seventh to the left of 0. Now, even though 1 seventh is to the left of 0, you can see it's actually much closer to 0 than 3 sevenths. 3 sevenths is 3 times as far away. So which is closer to 0? The negative 1 seventh. Just wanted to make sure you had a visual for that. Now the fractions you're dealing with, I think, are broken into fourths and halves and eighths. So you're going to want to find a common denominator and then go ahead and plot them on a number line with both negatives and positives. Good luck. I hope this helped.